All right, Algebra 2 students, this video is just to explain the two application problems in your notes from today. Different classes, we got two different final problems. So depending on whether you're in period 2, 4, or 6, you might have seen this first example already. But if you haven't, this gives you a good introduction to solving basic application problems where you are taking a written description of a problem and having to convert it into an algebraic setup. So we'll do one example that involves shoes and one that involves satellites. And this is one that you should watch before you attempt the problems towards the end of the homework assignment that do involve a lot of this translation from written or verbal expressions into writing things out mathematically. So let's take a look at the first example. We are dealing with here a shoes saleswoman at Saks Fifth Avenue who earns a base salary each day of $80. She then earns a 5% commission of total sales. How much must she sell in order to earn $115 in one day during the holiday season? So when we start to think through a problem like this, what we are trying to solve for is usually in the final question of the problem. So in this case, we're looking for how much she is going to sell. So the sales that she needs in order for something to be true. So let's piece together each piece of mathematical information, and that way we'll end up with one equation that we're working with. So here, the saleswoman's base salary is $80. So we know that no matter what happens with her sales, she's guaranteed to earn $80. Then it says she earns a 5% commission of total sales. Now, total sales is what we don't know. It's what we're going to be solving for. So I'm going to go ahead and define the variable S as representing sales. And I can say 80 plus 0.05 times the total sales is an algebraic expression that describes how much she'll make in one day, because 5% of her sales is 0.05 times the unknown quantity, so whatever amount she sells to people. Her goal in this problem is to earn $115. So in order to figure out how much sales we need, we're going to set that equal to 115. At this point, we can go ahead and start to solve for S. So I'm going to begin by subtracting 80 from both sides. So I've got 115 minus 80. And when I perform that operation, I'll have 0.05 times the amount of sales is equal to 35. My next step is just going to be to divide both sides by 0.05. So by 0.05 here as well. If you plug that into your calculator, so you do 35 divided by 0.05, you'll end up with the total amount of sales that she needs in order to make her given day's profit or day's earnings of 115 is going to be $700. And if you want to be even more specific and say in shoe sales, then you're all done with that problem. So a pretty easy algebraic equation to solve. We just need to make sure we're paying attention to the key pieces of written information. Let's try one more. The next one is about a satellite, and it says a NASA scientist is using an erbium-doped fiber amplifier in one of her satellite projects. When a signal enters the fiber, it has a signal of 12 milliwatts. At the beginning of the cable, each inch the signal passes through amplifies the signal by 700 milliwatts. After how many inches will the signal reach 3,000 milliwatts? So this problem is nearly identical to the one that we just did. The idea here is that presumably the satellite is sending out some kind of signal with a laser, and that signal needs to be amplified. And so there are different techniques for amplifying signals, and one would be this type of amplifier, an EDFA, or an erbium-doped fiber amplifier, which has some interesting processes that allow it to take a weak signal and make it a much stronger signal after it's passed through the cable. So, reading the problem, remember on the last one, we said to take a look and see what it says about in the last question to figure out what you're going to solve for. So we want to know in this problem how many inches of fiber are needed to get the signal that we want. We know that the signal is going to start out at this 12 milliwatts here. So I can say 12 is what I'm beginning with. Then after each inch, the signal is going to get bigger and bigger. And here it says each inch the signal is multiplied by 700 milliwatts. So I can say 12 plus 700, and then I'm going to go ahead and call distance. Let's use the variable d for distance in inches. In general in math, we would want to stay away from using the variable I for inches because I can be representative of other things. So here I'll have 700 times d for distance. So every inch I'm getting 700 more milliwatts of power. And now I have an algebraic expression that I can set equal to the total power that I want here, so 3,000 milliwatts. To solve this problem, I can just get started by subtracting 12 from both sides. So subtract 12 over here, subtract 12 over here. So we can go ahead and subtract 12 from 3,000, and we're going to get 2,988. And that is set equal to 700 times the distance. Next step is just to divide both sides by 700. And when we divide 2,988 by 700, then our resultant value is going to be 4.27 if I round to 2 decimal places. So 4.27 inches of fiber. And that would be our final answer. So again, we've got a baseline value, something that was changing with each increment, and set equal to some desired value, just like in the sales problem. Now, our linear expressions that we work with are going to become a little bit more complicated over time, but this general setup is one that we want to be really comfortable with. So on your next slide, you've got information about your homework. Other things to consider. Number 1, don't forget your summary. And again, that is not designed to add to your work in any way, but to help you turn your homework into a tool that you can better use for studying. Also, don't forget that you should be working actively to get your calculator if you have not done so already. And I will give you some specific information about graphing models and a deadline for your graphing calculator, which would be September 4th on the website. And you'll have some links to information about different types of models. Last thing, don't forget that your first quiz of the year is covering sections 1.1 to 1.3 in your textbook, and it will be on Tuesday. So that's what you can expect for this upcoming week. So I hope those problems were helpful, but please let me know if you have any questions about the application problems that you see in tonight's homework. Thank you, guys.